Welcome everyone to the ProTechTalks for this ProTech session. If you have not been to one of our ProTechTalks in the past, we select a group of expert panelists, and basically we throw questions at them that we're all interested in, various topics in the industry, and we've done that again today. As we get into this, I want to let everybody know that we're getting sort of a late start, so we'll probably try to go to about 1:30. And I understand if you need to leave early, please feel free to do so. Understand if you want to get back to a session or whatever. So we'll shoot for about 1:30. May cut it off a little early. So thanks for joining us. Hopefully this will be an informative discussion time for all of us. I guarantee you, we've got some of the best and the brightest here, and they're also not least bit bashful. So they may challenge you, they may challenge each other. So hopefully it'll be a very entertaining hour. But our theme today is completion considerations while optimizing operational efficiencies. Obviously, we're all about operational efficiencies. And so the question is, are we sacrificing something on the operation side, on the completion side, because we are so focused on operational efficiencies? So hopefully some of the answers to some of those questions and some insights will come out as a result of this hour or so session today. So let me introduce our panel. I'll start with Mr. Leen Weijers on the far end here. Leen is the Vice President of Engineering with Liberty Energy. He was formerly with Pinnacle Microseismic, and he went to Delft University in the Netherlands. Next is Jessica. We all call her Jess. Jess Barhaug. She's a senior completion engineer with Ovintiv, formerly with WPX Energy. She went to Colorado School of Mines. She's on the basketball team. Wasn't a real Paul team, I guess.
Next is Mr. Steve Asbill. Steve is the drilling and completion manager for Foundation Energy Management, formerly with Silver Oak, and he's a graduate of Oklahoma State, Cowboy. And last and least is Dick Leonard. Dick Leonard is a senior technical advisor with ProTechnics Division of Core Laboratories, as I am. My name is Buddy Woodroof. I too am a senior technical advisor with ProTechnics. Dick was formerly with Union Pacific Resources, and he is a graduate of UT Austin, although he seldom admits it. So that's the group. So we'll just dive into some of the topical questions that we have, and feel free to, if you'd like to get the opinion of the experts here, please feel free to do so. There's nothing magic about these questions. These are just ones they begged me to give them, so they wouldn't come up here not knowing what's going to be asked. So here we go. First question. What do you consider to be XLE? What is it really? How do you describe it? And under what conditions do you consider to be advantageous XLE? And under what conditions might LE be more applicable? Extreme limited entry and regular limited entry. Okay, I'll start with where extreme limited entry first began with the Liberty folks.
Oh,
Leen?
it's been around for many, many years.
Yeah, you
decades. So
You
no,
got it.
didn't start there,
But
but
Extreme on
kind of made you famous.
Oh,
Yeah.
yeah, maybe just a brief comment on that. I think there is a sweet spot, with limited entry or extreme limited entry, where, of course, our industry over the last decade or so has really tried to, make perforation clusters more efficient, right? Meaning that, can we cater fluid and proppant to every cluster if that's possible? And I think there's certainly, while we try diverter to get there, I think extreme or more extreme limited entry has been more successful, I think, and proven by several of you here at the table and many here. That I think, we do have the ability to cater that fluid and proppant to more perforation clusters. I think there's also an industry understanding that at some point you can overdo it, maybe erode your perforations too much, where then, later on in a job, as the erosion has taken place, you lopside your proppant and fluid to go into maybe the perforations that have increased in size, and you lost that limited entry or extreme limited entry pressure drop. So it's a balancing act, and I think this is not our finding, but I think the industry is typical. I think maybe in a sweet spot around 1,000, 1,500 psi of overall perforation friction at the beginning of a job. That's much lower at the end of the job, but I think we are looking for that sweet spot. That's all I'd say.
Yeah.
Thanks, buddy.
Anybody else want to touch on that? You have a different definition, how you describe limited entry, extreme limited entry. What's your
Sure.
target?
So, I mean, I think anything above 2,000 would be considered extreme. I think definitely, like Lane said, you can get down to like the 1,000, 1,500 PSI range, especially I feel like if you have shorter stages and if you're oriented, then you can really kind of drop down that perf friction and still get good diversion and erodible clusters evenly.
Anybody else?
I have to agree. I think we shoot for 2,000, anything over 3.5, 6 barrels a minute per. It's kind of our goal. We've seen some good filter efficiency from doing it. And we've also gone to the 0-3 phasing, which seems to help.
That's a good point. Perfect. Phasing. What's your opinion as to the optimum perfect phasing? I know it's different circumstances.
Don't there?
No, it's not on the list. Sorry. He brought it up. So how do you feel about perf phasing? What's your kind of your guideline on that?
Now you didn't let me answer the first.
Answer
You're
the
not
tough
an
one.
operator, so, all right.
We see a lot of things happening with regards to perf phasing. Obviously, early on, we were at 6 shots per foot, 6-degree phasing. That was easy because we didn't have to make that thought process on where to put them. But I think Steve's right. A lot of people are going to 0-degree. It's not universal across. Some people are adamantly opposed to it. So I don't think there's an exact answer to that, to be honest with you. I will say, wanting to just put a little bit spin on what you guys said initially with the extreme limited entry. And this is something that has been an issue within ProTechnics. We've been talking about limited entry my whole career here. And it used to be, we were begging people to get 2 barrels a minute per perf. That was just the magic rule.
Or even 1 barrel.
Yeah.
Per per.
And so where we've moved in that, and I think 2,000 pounds is what I often hear for extreme limited entry, but our biggest concern still, we still see it, is just the lack of uniformity within a stage as far as proppant placement. And extreme limited entry helped us get everything open, but oftentimes we're still seeing, runaway clusters and stuff like that. And so I still think we can do a lot better job of placing it uniformly.
You do have a preference?
And we're definitely in the 0-degree camp. We did, just mainly for food stress with velocity, just try to have even erosion. It seems like 0-degree kind of gives you that compared to bottom. We did test some 9270s in the Permian and saw the same erosion as we did shooting up. So it seems like at least that from that standpoint, that didn't really impact the erosion that much. Production wise, we'll see.
Okay.
It's also just, from profit transport, seems like down is preferable. It just makes more sense for that to make that turn up, but just from the erosion side, that seems to be the way to go.
What about you, Doc Ouija? That's his nickname, Doc Ouija.
We should do as we're told by our customers. But besides that, of course, opinion wise, I think there have been some interesting research by folks at Geodynamics, Colorado State, Colorado School of Mines, about kind of how proppant flow and fluid flow are not necessarily the same thing. And as proppant, due to inertia, has problems rounding the corner, going into the perforations. And of course, that depends on viscosity forces and things like that. So yeah, the the 9270 or the 4 o'clock, 8 o'clock, perforation strategy that I think some of them have advocated to minimize kind of that discrepancy in placement of fluid versus proppant. It's something to look at. I don't know if it's an overall driver, but at least something to acknowledge and kind of a bit of an eye opener if you've been in our industry for a long time.
Okay, let's talk about simul-fracs. Everybody knows simul-fracs. There's a cost efficiency issue with simul-fracs. My question is, are there other benefits other than the cost efficiencies that you've been able to identify? I heard you bring up simul-fracs earlier, so. Thanks.
Simul-frac, that's so yesterday, it's trimul-frac.
Sorry, simul-frac.
We actually are doing a trimul-frac right now. I mean, that's the main driver, cost efficiencies, and I mean, maybe you could argue, I mean, especially if you're trying to frac 2 wells in the same zone, and you could have competing stress shadows, so you wouldn't get the amount of length that you would if you weren't simul-fracking those stages. But if you design it, you're treating wells on different benches, and if you want to get some wells ahead and then simul-frac, I mean, I think there's ways where you can not really impact your production at all and still get those operational efficiencies.
Where are you doing a trimul-frac?
In the Permian.
Simul-fracs?
Well, to me, simul-fracs are great in theory, but there's not many basins that are allowed to do that. Like 70% of them are being done in the Permian. The Eagle Ford has a couple of Bakken and Tigers. I know in our area, there's just no way to do that. We don't have the space. We can't fill that many wells in a certain area to be able to do it. I wonder about how cycle time has taken over everything now, and are we really given a good thought to how we're competing and looking more at cycle versus speeds and timing? I know costs drive everything. You know, you can say $400,000 on a completion cost. That's big. Plus, you now have gas flow coming in quicker. So it's all about economics. I don't know. We haven't done a simul-frac, so I don't know or understand all the safety aspects of it. I mean, you got a lot of people, a lot of equipment moving. It's neat, but we can't do it.
We do. Are you finally getting non-frac? Thank you. Just telling me over here. Okay. What is your preferred SDI mitigation strategy? Preloads, order of fracking individual wells. That's kind of a big question. If you have a strategy for FDI mitigation, what is it? Like,
Well, of course, I don't have any wells. But I think typically, of course, at least some pressurization of nearby wells, I think to minimize the chance that you sand off, some of your offset wells, just to prevent the cost of cleaning that well out. But of course, that depends so much on kind of your local circumstances, your experience with it. So I think that's on the service company side, of course, again, we're doing as we're told. But I think there are some very cheap, relatively cheap strategies to at least, operationally keep costs down significantly. And then I think what you do in addition to that, to improve well performance and things like that, that is very, I think, area dependent.
That's good. When you're doing your simul-frac, are they all full day or up in the day or?
We're at 185. Split, yeah. Yep.
you've been out on the simul-frac. There's 2 wells, 100 barrels, 1 in each.
No.
I was out on one years ago.
Big wonders.
Yes. I was out on one a number of years ago, and I could have sworn when they were both fired up 100 barrels, I mean, like 2 brown. I know that doesn't sound plausible, it sure looks like it. Everything's sort of shaking, that's a bit of a reflex. Oh, come, bear up a minute. I mean, if I can see how many frac pumps we have. You have a Canadian crew, you have a US crew. Kind of gives us some problem because there's all the batteries.
Figuring out the software.
What's this
between
barrels
each
per
other.
minute stuff?
Yeah.
Put it in cubes, man.
It was interesting.
You've probably been out on some of those 100 barrel a minute.
Oh, yeah. Oh, yeah. And it's, you know, I didn't comment on the simul-frac. I guess that our biggest concern has been that if, you know, and the Permian is got a lot of things going for it. It's probably a little more forgiving in terms of getting the jobs away. In some of the basins, I just get concerned that, and we've just seen this even with zipper-fracs, that every stage can treat significantly different. And I think one of the keys in terms of the efficiencies on a simul-frac is you got to kind of at least go into it thinking everything's going to be treating fairly uniformly, because as soon as you start losing one or having to do something, you're really, it affects the other one too. So, good point. And I think, you know, your other question,
Yeah.
that you just had.
Yeah, mitigation.
So, I mean, and that's, I would say it's, you know, very much basin specific. You know, we've done a lot of refracs through the years in the Barnett. And, you know, we've done some refracs with foundation, and, you know, we tried preloads. I think, you know, we have a refrac workshop every year, and that discussion comes up, and I don't think it's been the best technique. I think from year to year has changed dramatically. I think one of the problems with preloads is you got to really be committed if you're going to do it and pump a large enough volume. And in a lot of cases, you're just not practical. I know the job Steve did, we pumped a lot. We traced it to try to see where it went. Thought we had gotten everything, and we pumped the frac job and it went right back where it all went initially. So
That's a little discouraging.
it was discouraging.
What basins?
That was in the arc on the Woodroof. And we pumped enough diverter to sink a ship and could never get out of it.
You plugged up something somewhere.
I don't know where. it went.
Yeah.
I think our,
For simul-frac versus zipper, depending on the water and the formation, sometimes you can pick up the signal that the production performance of the simul-frac are reflective of fractures that are not infinitely conductive versus the production performance of a zipper-frac are reflecting of fractures that are infinitely conductive. And this is what's nearby. We're doing an analysis on it. I'm not saying that, I mean, if there is an URTeC, but it's just because of that extra pressure drop that you're gonna get for that not infinite conductive fracture, it shouldn't be big, and probably might be overcome for the savings that you're getting still. But to me, from the reservoir side, it just made me wonder what's happening down there differently. That, you know, I'm pumping the same job, just somehow my different operational mechanics that I'm doing, I'm not getting the same down there. Or at least not in the same configuration. Maybe it's related to fluid versus sand again. I don't know, it's complicated, but that was an interesting observation that we had.
Good point.
Can maybe comment on that.
Okay.
Now, from a physics perspective, simul-fracs are, well, easy to, I think easy to justify, right? Because the fact is that wellbore friction scales with the square of the flow rate. So if you have, say, if you're pumping 150 barrels a minute in a single well, you have, say, 4,000 PSI of friction. If you pump at half that rate, you only have 1,000 PSI of friction. And, you know, if you adjust your staging on the two wells that you're doing to make it more similar to the one well that you would be doing instead, I think there's a no-brainer benefit. And that's why I think our industry in the next 5 or 10 years, and Jess is already doing it, we're going to 3 or 4 wells at the same time. That's the trade-off. Operationally, if you can handle it properly, but definitely on the friction side and the amount of horsepower you waste on overcoming friction, that I think is a great way to get around it. Now, I think how you price that out, I think, you know, there's sometimes a bit of a, you know, of course, a discrepancy with what operators think and what service companies think. And, but anyhow, yeah, like most other things, but physically it makes perfect sense. And then I think the icing on the cake is, downhole, do you benefit from the stress shadowing, et cetera? Is there additional benefit on the production side while you explore it. So I think the industry will go there, and it's already going. But I think in a couple of years, I think all operators will try and, you know, use that at the same time with zipper manifolds, actuated and whatever. So relatively easy to make kind of the operations work. Again.
Find that, I mean, really, the Permian is really the best spot. These are cheapest.
I mean, we did it in the DJ too. It was a Great Western. I mean, yeah, Liberty was doing it for us there in Halliburton. I mean, that one, we were doing cross-link gel and kind of lower rates to begin with, so it wasn't a huge operational change. We didn't have to have any boost pumps or anything. We're just doing the max rate through the blender. So, but I mean, that was kind of a little more strategic of pairing wells together. Just because, I mean, some of the Nile benches would treat a little differently and what else, so I mean, you did have to, the Permian and we did some Klein wells, those were definitely higher treating pressures, so we had to pair those together as a simul-frac pair, but then with the upper stack, it's even, yeah.
But have any experience with simul-fracs, good or bad? Share with us. We're all losing your mouth, yeah. Okay, well, we're gonna leave that. We don't have food yet.
Potatoes.
Any experience with simul-fracs over there? Okay. We can move on. We'll go back to the guys still. Yeah, I didn't get much great strategies.
We've done a number, preloads. We've done, we've really kind of gone to try to do a real time where we're shutting our wells in, our parent wells, and putting bottom hole pressure gauges in them to where, now I can monitor that bottom hole pressure in the van. And we've seen some interesting things. We don't get too concerned if we see 100 PSI increase in bottom hole pressure in our offset, but we had this last one where we had a 1500 PSI and it loaded our wellbore full of 100 mesh sand.
That's not what you intended.
No, it was not. So we're also using some of the seismos stuff, but I think it's, our mitigation now is, and it's strange because in the Arkoma, it changes from county to county as you go, because it's very, very fractured up north. And as you go down, it's not as bad. So we're seeing bigger hits up and then really natural fractured stuff. So we've gone to basically smaller volumes of water and, just trying not to hit them so hard. Again, it's very, like I say, you move 5 miles south, it's a different reservoir.
Dick, you remember back in the early Barnett days? The FDI mitigation technique was just basically like he was saying, just shut in the offset wells.
Yeah.
You had a pretty good chance of not hitting them in the Barnett at least.
Spacing's a big thing too that we're learning,
It's pretty forgiving too.
Yeah.
In that regard as well. I mean, we usually keep wells flowing. If we see something, we'll shut them in. I mean, if they're really close, we'll shut them in, but. And yeah, you don't really have to do anything in terms of FDI mitigation on the parents. Not really the case in the DJ. That one was definitely shut it in. We did fill-up jobs. We just did random 20,000 barrels, but it seemed to help. We were standing off well boards, and after we just kind of smaller fill-up job, you couldn't really see the impact anymore.
What's so magic about 20,000
I don't know.
barrels? That's the number you always hear.
Yeah.
Who came up with that? Why are we sticking with it necessarily?
Regardless of the well length.
Yeah, 40,000. Yep. Drop boards.
We don't refill with more of a. Actually, we're gonna do a refrac. I said, we'll try to fill it up and not drag it. We didn't get, well, put it down, get my iron down.
A little more logic. Okay.
I just found people use the volume, equivalent to how much production you have from the offset rate. Max that volume.
That's not, it's not a good way to go.
No, okay.
We actually,
Wasn't my
with our
idea.
pre-fill, hit another well and killed it.
So that's bad.
We put 400,000 barrels. It was not good.
That was very trying.
The other thing on the fracture driven interactions and mitigation is a lot of it is a function of how old those child wells are. how much depletion you have
Yeah.
is a huge thing. You know, one of the benefits in refracs is if you can get it quick enough. Some of the challenges that BKV has in the Barnett, you know, some of those wells are 15 years old and they would be great candidates, but they're also so depleted, it is very difficult to overcome that and stuff. And so I think that's a challenge. I don't know if you guys want to comment at all, Kevin, about your guys' thoughts on mitigation or anything, but
So, well,
Sam,
in the Barnett, you know, brackets or FDIs, they're, not afraid of. They actually boost the production of our offset and vertical wells. So we've had, for example, I think we showed some recent workshop. We had one pad where we drilled 2 new wells, another one where we drilled 4, and there were 22 to 25 vertical wells completed in the Barnett Shale around there. And those vertical wells added as much production as, in one case, had 1 new well. And then on another pad, added enough production as the 2 wells combined. It's amazing amount of additional production we get out of stimulating
you saw
stuff in the wells. So, yeah, so in the Barnett, we don't try to prevent them. We don't try to mitigate. In the Marcellus, what we've done, where FDIs have a horrible impact, just totally destroy offset wells. When we think there's a higher risk, for example, if our well spacing getting closer, you know, our well path has come on, we're closer to a different well, or we're just in an area where we think there historically has been more problems. Going with a drier frac design, rather than 35 barrels of water, we will go to like 25 barrels of water per foot. And then also we kind of develop rules of thumb where we do monitor the pressure of offset wells. And if we see a certain level of increase, like 20 PSI increase in the wellhead pressure of offset wells, then we cut that stage on that frac that's being fracked. We're monitoring it real time. And those 2 things have really helped us in the Marcellus.
thank you, Kevin. You set me up for the, okay.
FDIs in the Bakken are a great thing too. When we, you know, we had numerous middle Bakkens that, you know, they were 3, 4, 5 years old. And then we come in and drill 3 forks beside them. I've seen over 400,000 barrel uplift on the middle Bakken well that got hit. And we still got our type curve on the 3 forks.
So how long is improved? The Bakken is very good practice. Very area dependent, obviously. Whether you're beneficial or whether you should do it at all. But getting back to what you said there, Kevin, how close are we really to real-time frac optimization? And if we're not close, what are the missing pieces? Been at this a while and rarely do we see anybody taking any really proactive steps during the frac, other than just shutting down. That obviously upsets some the service companies, you know, that have all that profit out there that's not going to get profit out. So, what do you think? How close are we? Come on, Lane.
I think it's an insulting question. You know, we've been doing that for 30 years as an industry. What do you mean? What kind of question is that?
Real, true.
Real time. Okay. Well, let me tell you this. I think real time optimization is, you know, and of course there are things we can do, but think about kind of the logistics about your frac operation today, right? Proppant is ordered, sand is ordered maybe 3 weeks ago, you know, for this well, you know, the chemicals and etc. that we pump in bulk, you know, and that we have in bulk on your location, you know, have been ordered a while ago. So how real time is that? You know, if you want to, you can't really change your fluid system. You can't really change your proppant. What you can do is maybe reallocate, right? Maybe based on some measurement or something like that. But I think the dream of real time, you know, evaluation and decision making, it's tough. It used to be simpler maybe in days where, we would have a vertical well that's being fracked, tomorrow we're doing 2 stages in the Niobrara and the Codell, that's it, and we can maybe adapt more to that if we wait or, if we get other problem on location and things like that. But the reality, I think, of it today is that, supply chain and the logistics associated with what we do in a frac job, it's hard to make massive changes. But is it possible to make smaller changes based on diagnostic projects and things like that? Again, the reallocation, I think certainly so. And I think if, operators spend the time in real-time diagnostics, that there are some of these decisions can be made, maybe as simple as shutting off a frac job when you see interference in another well, maybe, skipping perforated intervals based on log data or other, maybe more sophisticated log analysis. Certainly, I think I think if there's a desire to, I think we can do that today. But I think, bigger decisions, that's a tougher one in real time.
So small changes, yes. Massive cut off extra frac.
Well, I think if it's with the same, again, I think if you have major fluid system or proppant system changes, that's tough.
Okay. All right, here's a $100,000 question, one they probably all working hardest at. If you had a $250,000 budget to spend on completion diagnostics for a pad, how would you use it? Okay, so getting answers from everybody. 250 grand to give it over. No. 250,000. I think I know what probably one of the things.
Yeah, I mean, my boss is sitting right there. I'm not gonna.
But I will say, and some of the stuff we did with Steve on this last project with Foundation will be multiple technologies.
I really think there's a huge benefit to that in that there really isn't a technology out there. I mean, tracers are the closest, but that answers everything. And so getting, a portion of it going to different coming from different directions. And if you're trying to optimize, and a lot of the optimization is really optimization of future development. I think having multiple technologies giving you a similar answer just gives you much more confidence that you're really making a good decision. That would be my position.
That's kind of a general answer.
It is.
I was hoping for some specific technologies that you.
249,000 would go to tracers.
Yeah.
Okay. No, I mean, I don't know. Each project's different. I think the reality is with the number of stages being done, the length of the laterals, $250,000 doesn't go as far as it used to. And
One state.
Say that.
but I think there needs to be a balance. We don't do as many science projects anymore. I think there's just logical things in an operator's development plan that early on you want to learn as much as you possibly can. I think there's some good work being done with not only what we're doing and trying to apply things in a different way. So not more general, but they can give you more of how much they're going to give to ProTech.
Well, Lane probably remembers, we asked the same question a couple of months ago in Scottsdale, and we had a slew of answers. It was all over the place. Some of them were a little silly, like buying a new car for the field hands, stuff like that. But okay, you just had a big project. I fully expect you spent more than $250,000 on completion diagnostics. So
It was pretty close to that. I mean, I think we were right around the 250. Yeah. Well, where we used flowback tracers, proppant tracers, we used seismos, and we did AHS and did a bunch of rock mechanics. We're in a very faulted up area, fractured up in the Woodford Arkoma. And, it opened our eyes to a lot of things. And from that 250,000, I think we, landing zone, it showed our flow back from our different landing zones, which, we were trying to keep it in a 20-foot window because it was the most brittle, best rock. But now we're seeing that, we're getting as good a flow back from our second landing zone. So, we can speed up our drilling. We can, I bet we can reduce our cost $600,000-700,000 on the next well from just the things we learned. Lot less volume on our frac. We going 60 barrels a foot. We can probably go 30 barrels a foot here. I think it was really good with the way the seismos, the rock, and the proppant and flowback tracer all tied together pretty good. So
Okay, Jess? You've used them all pretty much.
Have 250.
Okay, go ahead. I'm gonna write them down here.
Well, I feel like kind of where there's sometimes a disconnect between science projects before design management is like, so what? What's gonna be the big driver here? Are you gonna improve production, decrease costs? So I really like the diagnostics that do directly tie to production, because that just always seems to be the question is, okay, what did it do? So and I like testing things in a single wellbore. I think you can get to that 250 if you just alternate different, either testing like stage architecture, profit volumes, things like that in a single well. So I do that. I mean, I hate to say it, but the oil tracers make sense.
What is so hateful about that?
You guys, I mean.
No pressure, no pressure. Go ahead.
No, I really like the just compatibility testing that's been done with the oil tracers and having that portfolio that's specific to reservoir. Makes sense. So just doing the ABC testing, I'd like to pair that with like a frac ID or a CORDAC, something like that, just to see if there's any sort of geologic anomalies that you need to be aware of. And then I think just having some sort of diagnostics at the cluster level, if you are really looking at stage architecture, is ideal. So just to have like a carbon fiber rod in the hole kind of a month or so after you turn the well on, just to get that initial classification and then have those tracers for long-term production. And then, I mean, depending on what you're testing, you should have some results that you could bring back to management and say, hey, this is how this design that one, and actually have a more complete answer in a 6-month period. Then, I mean, I love the you get with like express fiber and pressure gauges and all that stuff during frac, but it'd be nice to pair those all together, but then you're still just kind of missing that. Okay, how did it perform? So.
Lane, what do you say?
I agree with Jess that, and of course, with the other panelists here that, of course, the diagnostics you select depend on what you want to know. But I think ultimately it's also a matter of convincing people, management or whatever, okay, what have we learned from the strategy and what are the upside for production? And that's why I think also looking at, for example, the statistics, what are your neighbors wells doing? What are wells doing across the basin? I think, and maybe I'm a contrarian here now, but that $250,000 I would spend on pumping 10% extra proppant. And, with the 10% extra proppant, if you look at most basins, even statistically, right, that's a 3% improvement in production. That pays off in 6 months. Typically, for the price of oil we have today and for the production uplift you'll get, it's minimal. But there's often a significant bang for the buck you can have for slightly larger designs, if you can live with the FDIs and things like that. And those are, I think, that's where the discussion about use of diagnostic needs to go as well. Well, can you, based on what you recommend, then say, we need to upscale this or do this differently. And, if we look at what other operators have done in this basin for the same formation, et cetera, we see an X% uplift that can easily pay for, diagnostics we want to spend. I love diagnostics, don't get me wrong. I grew up in that world, and I think there's a lot to do with calibrating models and better understanding these sensitivities. But I think we need to do a better job selling them, just like the statistics of 10% more proppant, 3% more production. That's an easy sell, I think, although nobody.
I have a question for you. There's got to be some point of diminishing returns.
Oh, for sure. Oh, yeah,
And
absolutely.
so I'm guessing by your answer there, you really feel we still haven't gotten to that. most of the basins.
In many places,
Okay.
there's room to go, yeah. But certainly, that's absolutely, and exploring what these bounds are, that's important. So instead of incrementalism, of going from 2,000 pounds per foot to trying 2,200, try 5,000, and that's what some companies have done. And then probably that's over designing it. But I think there's room in many cases that you'll find.
And I think the key is doing things like that, and this kind of ties back to what Jeff said.
Running some diagnostics to evaluate it. You don't have to do the whole well. You can do individual stages. That's some of the, and I agree. I think some of the discussion we're going to see over the next couple of years is going to be much more discussion on cluster level interpretation of what's happening. Yeah,
There are some new diagnostics out there.
I've heard about those. Yeah.
I will add that we did do some things that were free. We actually, yeah, we performed some,
Go to another question.
we performed some ghost stages, on about 30% of our stages.
Okay.
And, we did see through the seismos, we got about 10% better in FCI. And with the flowback tracers, we are seeing that it looked like we're actually getting a little better flow back from those areas. We also did, we went from 1,500 pounds to 2,500 pounds on a couple stages. Those looked a little better. I'm definitely a proponent for more sand. Always. I just have management problems.
Okay.
What's a ghost stage? You wanna answer?
Basically, what we're doing is, like, we'll go up to 1.5 pounds, and then we'll basically do a sweep, and then we'll do a hard shutdown with our pumps, and then bring them right back up. And, we might be treating at 4,500, 5,000 PSI. And when we do that ghost stage, I mean, we've seen 1,500, 2,000 pounds of extra pressure. So we think we're doing some type of reorientation with the clusters, the rock or something, but we've definitely seen some benefit from it.
And some
It
of
doesn't
that,
cost anything,
Increase.
increased pressure.
some of that early came from testing diversion. That was the concept. I know Chad had a paper we wrote where did everything like you were pumping diversion, except don't pump any diverting material. So you're slowing down or shutting down, things like that. And we saw a similar sort of thing. We actually saw better cluster efficiency, performance was slightly better and things like that. So in certain basins, it definitely has some applicability.
That concept has been around since the 70s.
Yep.
Is it-
Keel fracs, yeah.
Under keel.
Keel fracs. It's like we just discovered this,
Yeah.
It wasn't
We
called.
just
ghost.
renamed it.
Okay, we're getting close to our cutoff time here. So we always like to end with a personal question. So, and I realized this wasn't on the list
That wasn't
either.
on the list.
No, it's not. So what I'd like to ask each of you, just out of curiosity, you all went to fine academic institutions with maybe one exception. And just out of curiosity, who were some of the, and maybe not even in college, who were some of the mentors that were very important to you in your career, starting at the college level, all the way through your professional experience? I'll let you volunteer since you gotta give that some thought. Who's got some candidates? All right, who are your?
Well, I would say, the reason I'm in this industry is, my dad's love for hunting fossils. And so I loved that as a child and wanted to do something engineering wise. So it starts there, I think, with my dad. But then, yeah, I think if you're lucky enough in your academic career and your professional career, you see some people that really, I think, speak to you and are great examples. I definitely had two professors at Delft University of Technology where I went that spoke to me that way. And then my current boss, Chris Wright, I think is another example professionally that I look up to and I'm lucky to be associated with.
I should go. So yeah, at my bachelor's was actually in environmental engineering, because I thought I wanted to restore beaches. Yeah, I got environmental and master petroleum, so I got both sides. But during the summers, I actually went and worked for my dad and my uncle. They had a small operating company up in Casper. So I was doing everything, building poly pipe, doing surface use agreements with landowners, some that would meet me at their house with a shotgun. But yeah, I just got to learn every facet of the building of the business through them. And so, I mean, my dad had inspired me to go back and get my master's in petroleum. And then during my master's, my original advisor actually quit and went to work for Chevron when I had like 3 months left. So Ramona Graves stepped in and took over my work and helped me get across the finish line so I could defend my thesis and graduate on time. So she was definitely one of my mentors. And then my first boss out of school, Schlumberger, was Belu Cherian. And I mean, he just really taught me everything that I need to know in terms of frac, and we still keep in touch with him. And so, yeah, those are mine.
Well, speaking of fathers, I think in my case, my dad, he taught me to work ethic. He worked for the same company and killed the company just so. And it's right up from office boy to mid-level manager. He just taught me the value of hard work. So I certainly have to put in a lot of individuals in the industry. George Keating is one. Been a mentor for me, and many others. Go ahead. Who's your dad? Everybody else.
He was a petroleum engineer as well, mechanical. But I think probably my first boss at BP, he introduced me to John Ely. So they were really good buddies and learned a lot from John Ely, and we got to do a lot of things. But I'll never forget the first thing my first boss said was, he goes, I'm going to let you make mistakes, but I'm not going to let you sink the ship. And
Good advice.
guaranteed from the mistakes I made, I learned more from those than I have anything else.
You always do.
So
Dick, who were your mentors?
So my dad was a chemical engineer, so, yeah, he worked for Shell his whole
I
career.
didn't vote them up on this, by the way.
I think, early in my career, I had a boss similar to what Steve had. And actually, you've asked this question to other panelists, and John Applegath's name was brought up, and he was one of my early bosses, and he challenged me, let us make mistakes, but I like the way you put that, didn't let us sink the ship. I think from an overall industry perspective, I was talking with someone yesterday about this. Steve Holdridge probably had more of an impact, not necessarily on me, but on the entire industry, not only through his work in, he was an ag guy, I have to discount that.
Nobody's
But
perfect.
you look at leaders at these companies and some of the best people in the business, a lot of them came out of Holdridge and Associates. So.
True. Okay. Don, did you hear this thing about it's all right to make mistakes? You learn.
I heard that. I heard that. Anyone have any questions?
Yeah, any questions from the audience before we?
Somebody said something about diverters, they were. Thoughts on that?
Let me take that. I'll give
That was
you,
on my list, actually.
I will give you my opinion, and a lot of the diverter companies don't really like me, but I think some of the early work with diverters, we were just pumping it and really didn't have a plan. And hey, it's going to plug up something great. Our work didn't really show it working. We differentiated between diverting and effective diversion, and most of the stuff, yeah, it diverts. You'll get a pressure increase or something, but are you really doing what you're trying to do, which is open new rock and shut off where currently being stimulated? Where I think diverters possibly have a potential benefit is with regards to FDIs. If you are hitting something, and I don't really know enough about the designs of far field diversion, but I've seen some places where that has worked. They pump it and it definitely mitigates it. And we've confirmed that with some of our diagnostics. So
we saw that on the Edwards.
we did.
We're talking about the Girl Scout knots. Huh?
I'm not even gonna say which ones, but yeah,
Somebody else, what's your experience been with diverters?
Not great.
Not great. Okay.
The numbers speak for them, right? So I think, maybe 3-4 years ago, diversions were quite kind of a hot topic. But I think, that has been taken over by, I think, a better way to cater to perforations, in clusters through limited entry or some kind of design, restricted fluid entry design. And I think, today you don't really see, in our databases, the amount of jobs that have diverters is extremely minimal.
The engineer designs and perforating like rock as well.
Yeah, I agree. I think that's engineered designs are so rare these days. Everybody goes geometric. Doesn't make any difference if I go all this trouble. I agree with you though.
Yeah, simul-frac
Simul-frac.
with engineered designs,
Think about that. More effort on your part.
make it a lot more complicated.
Maybe a little bit, yeah. Some efficiencies.
Any other questions? Anybody? Something that you always wondered about? Just didn't know the right person to ask. Okay, well, thank you.
thank you.
Everybody for attending and
Good job.